Question number 24. Triangle ABC and A prime, B prime, C prime are drawn on the grid provided. So the two are here. The first question, part A. Describe fully a single transformation that mapped triangle ABC onto triangle A prime, B prime, C prime. To describe this transformation, you need to have a keen look at the object, which is triangle ABC, and the image, which is triangle A prime, B prime, C prime. When you look at these two, you notice that there is a change of size. The image is bigger than the object. So you need to think of the transformation that changes the size of the object. Which transformation changes the size of the object, but the shape remains to be the same? When you look at these, triangle ABC and triangle A prime, B prime, C prime, you notice the shape has remained to be the same. The only thing that has changed is the size. So automatically, you know that this is an enlargement. This is an enlargement. How do you describe an enlargement? An enlargement is described fully by giving the center of enlargement and the scale factor of enlargement. So let's begin by getting the center of enlargement. Now, to get the center of enlargement, you pick the object point, let's say A, you join it to A prime. That is the image point. That is what I'm going to do. Pick another object point, say B or C. I will choose C and join it to C prime. Those two are enough to give you the center of enlargement. So we've picked object point A, join it to A prime, then C, join it to C prime. Where are the two lines meeting? They are meeting here. That is the center of enlargement. So the center of enlargement. So we've noted that this is an enlargement. So this one is an enlargement. That is an enlargement. Center is the origin. That is where the two lines are meeting. And then you need to get the scale factor. You need to get the scale factor of enlargement. How do you get the scale factor of enlargement? Now, there are two ways. Just go to this one. To get the center, the scale factor of enlargement, to get the scale factor of enlargement, you just need to get one line, let's say A prime, C prime. So I'll get to get the scale factor of enlargement, we'll get A prime, C prime. Then you divide by the corresponding length on the object AC. So divided by AC. So this one gives you what? You just take the measurement. You just need to take the measurement using a ruler. So just take the measurement of so this one is giving so this is 6.123, around 6.4. Then you take again this one, this one is 3.2. So when you take that measurement, you notice that A prime C prime is 6.4, then AC will be 3.2. So when you divide these, you'll get this one as 2. It's going to give you 2. So that is the scale factor of enlargement. But that is not all. I want you to have a look at the center of enlargement, where the center of enlargement is. Look at where the object is, and look at where the image is. When you notice in an enlargement that the object and the image are on the opposite side of the center of enlargement, then the scale factor of enlargement is negative. So in this case, I want you to have a look at this. Just have a look at where the center of enlargement is. The object is on the opposite side. The object and the image are on the opposite side of the center of enlargement. For a positive scale factor of enlargement, the object and the image are on the same side with the center of enlargement. For a negative enlargement, the object and the image are on opposite side of the center of enlargement, and this is the case. So this will be the scale factor of enlargement, therefore will be -2. So we have described this transformation. It is an enlargement. The center of enlargement is given. That is how we describe enlargement. Then the scale factor enlargement is given. Let's go to part B of the question. On the same grid, draw one triangle A prime, A double prime, B double prime, C double prime, the image of triangle A prime, B prime, C prime, under a rotation of +90 about the origin. So we have now we have this one A prime, B prime, C prime. We are supposed to rotate this one about the origin, about 0, 0, and through an angle of +90. +90 degrees means that you're going to measure the angle in anti-clockwise direction. For negative angles of rotation, we measure the angle in a clockwise direction. So how do you go about this? Just join each point. Let's rotate A through +90. This is A prime. Join it to the center. Join it to the center. That join it to the center is already joined. Then place your protractor and you measure -90 So 90 degrees, we're measuring the angle from this. This is anti-clockwise, so from here 0 all the way to 90. So 90 will be here. So 90 will be there. So join these. So join that one using a straight line. Then take this measurement out, locate the image of A prime. So that distance, take that distance. So take this distance from A prime to the center of rotation, then transfer that distance, mark the distance there. So you notice this is the point, it's going to be here. So this is where we have A double prime. Let's join B. Let's join B. Join B. join B to the center of enlargement, then place your protractor there. Then you measure the angle in anti-clockwise direction. So 90 will be there. Join. Take the distance B prime to, so take the distance B prime to the center of rotation, then that distance should be same, so you mark, so you get these will be B prime, B double prime will be there, so B double prime will be there. So you have to take this distance after you measure 90 degrees B prime to the center, then transfer the same distance along this line, so you get B there. So we're remaining with C only now. So let's rotate C. Measure 90 degrees. So 90 degrees will be from here, 90 degrees will be here. Then you join. Okay, as you do that, then take the distance, C prime to the origin, that, so the same distance, transfer it there, so you get this will be C. So you have C double prime is there. Now you have all the points now. A double prime is there, B double prime and C double prime, so join them. And there we get the image of A prime, B prime, C prime, and a rotation of positive 90 about the origin. So we have triangle there. The next question, so we have drawn that and it's done. 2. Triangle A triple prime, B triple prime, C triple prime, the image of triangle A double prime, B double prime, C double prime under a reflection in the line y is equals to negative x. Now which is this line? Y is equals to negative x. Y is equals to negative x is this line. Is the line that passes through the center of this here. This is the line that passes through center. We will not draw these one already. You can see it is there. You just need to extend it. So this is the line. Y is equals to negative x. So that is the line. So we need to give the image of this triangle when reflected along this line, y is equals to negative x. So for that one, there's something that you need to know. For this kind of reflection, the points are interchanged and then they change the sign. For this kind of reflection, y is equals to negative x. The points for any general point, let's say AB, if this one is reflected along y is equals to negative x, you get negative b, negative a. Note what is happening to the points. They are interchanged and then they change the signs. So you need to get the coordinates of a double prime, which will be 8, 2. A double prime is 8, 2. So a double prime is 8, 2. So you need to get what will be. So b double prime, that one is 6, 6. That one is 6, 6. And then C double prime. C double prime is 2, 4. 2, 4. So following this concept and the reflection in the line y is equals to negative x, the points are interchanged and they change the sign. So A triple prime will therefore be negative 2, negative 8. So B triple prime will be negative 6, negative 6. Then C triple prime will be negative 4, negative 2. So all the points are interchanged, change the sign. So we need to draw these. So A triple prime will be negative 2, negative 8. Plot that. Negative 2, negative 8 will be here. So A triple prime will be there. Then for B triple prime, negative 6, negative 6. So negative 6, negative 6 will be here. And then lastly, C, we have negative 4, negative 2. Negative 4, negative 2. So C triple prime will be there. So then you join them. And there it is. So you can see this is the reflection, this image. So that gives the reflection of this object, that is A double prime, B double prime, C double prime along this line y is equals to negative x. The image will be here. Then you're done with that. Part C of the question, draw the line of symmetry of triangle A prime, B prime, C prime, and hence determine its equation in the form y is equals to mx plus c, where m and c are constants. So draw the line of symmetry of this triangle A prime, B prime, C prime. We get the line of symmetry. The line of symmetry is the line that divides this triangle A prime, B prime, C prime into two halves. The line that will divide these into two halves. So when you look at this triangle, first of all, triangle A prime, B prime, C prime, you notice that this length, the length C prime, B prime, and A prime, B prime are equal. So this one, if you measure these, is equal to this. So if you want to draw a line of symmetry, we shall have a line that cuts through, passes through here, the middle of these. So let me draw these. So that line that I've drawn, I want you to look at this triangle again, A prime, B prime, C prime. So we have established that A prime, B prime is equal to B prime, C prime. So this one is an isosceles triangle. So if I draw a line that passes through the center here, then the center of A prime, C prime, see, this line is passing exactly at the center. This will be the line of symmetry that will divide triangle A prime, B prime, C prime into two halves. So this is the line. That is how we draw it. It must pass. You just need to establish the midpoint of A prime, C prime, which is this point, and then so that line of symmetry should pass through this point here and this point. So you can see these are two halves. So to get the equation of that line, you just need to get 2 points on that line. They can get this one. So this is 6, negative 6. You can get this point. This point is 6, negative 6, and I can get this point here, 0, negative 4. So as long as the 2 points are lying on that line, so we have 0, negative 4, and 6, negative 6. So 6, negative 6. So we pick 6, negative 6, and 0, negative 4. So let me show you the lines again, and the points again. So this is the point, 6, negative 6, and 0, negative 4. So I can use those two. You can pick any other point. So how do you get the equation? You get the gradient, a change in y, that is negative 4, subtract negative 6, that is change in y, over the change in x, 0, minus 6. This will give negative 4 plus 6, which will give 2, divided by negative 6, and this one will give negative, and that is a gradient. So once you get the gradient, you can just use, I can pick 0, negative 4, and I can introduce another general point on that line, x, y. I can use these two to calculate this gradient. So gradient is change in y, so y subtract negative 4, which will be y plus 4, divided by x subtract 0, which is x, is equals to negative that. So if you cross multiply, this is 3 times, so 3 times y plus 4 is equals to negative 1 times x, which is negative x. So this will be 3y plus 12 is equals to negative x. I need that equation in the form y is equals to mx plus c. Therefore get 3y is equals to negative x minus 12. Negative x minus 12, so y is equals to negative a third x minus 12, this minus 4. That is the equation in the form y is equals to mx plus c. That is how we're supposed to solve that question. Thank you.